Hello and welcome to this video tutorial on how to use the FlexSim Healthcare software to build a simulation model of a small healthcare clinic where patients will arrive, register, and receive treatment. Before we get started, let's first make sure we're in the healthcare environment. If we're still in the standard FlexSim environment, there is a button on the far right of the main toolbar we can use to switch the environment to healthcare. Okay, let's get started. Create a new model using the menu File New. A window will pop up where we can define the units we want to use in the model. These preferred units must be declared at the beginning and shouldn't be changed after we start building the model. We're going to keep the default units of seconds and meters for this tutorial model, so we'll just press the OK button. Let's begin by first importing a CAD drawing of the clinic's floor plan. On the main toolbar, click the Floor Plans button and select Add a Floor Plan. Next to the File Name box, click the Browse button to open a file directory dialog. Navigate to our computer's document folder, then to the FlexSim Projects folder. The CAD file we want should already exist in this folder as a result of installing the FlexSim software. We'll double-click the file named er_small.dwg to select it. The FlexSim Healthcare 3D library has a set of objects that are specifically designed for building healthcare models. Patients and staff will move to these locations and interact with them based on the specific type of object it is. Usually, the interaction will involve changing the animation of the patient or staff when they arrive at or leave the location. For example, when patients arrive at a chair location, the object will start an animation on the patient so they will sit down from a standing position. We're going to begin by creating just those objects we need to model the front area of the clinic. This will include a front door, a kiosk where the patient can sign in, and a waiting area where the patients can sit and wait. First, let's create the kiosk by dragging a kiosk object from the library's location group to the 3D view. We can reposition the object by dragging it with the mouse, and to rotate the object, we can right-click on these colored arrows that pass through the center of the object like this. Or we can type an exact value into the Quick Properties field. In this case, 180 degrees is what we want for the object's Z rotation. Now let's make the front door where the patients will arrive through. Let's use the glass door object in the library's prop group because it has a cool feature built in that's going to animate the glass door sliding open and then closing when patients arrive. We'll position it here. Next, let's create a sitting area where patients can wait to be taken back to an exam room. For this, we will use a multi-location object called chairs. We will position it here and rotate it about 45 degrees by right-clicking the blue arrow and dragging it like so. We can change the number of chairs in the multi-location object and even position or rotate each chair individually if we would like. We're not going to do this right now, but to do so, we would first need to check this Edit Mode box in the Quick Properties panel on the right. Let's rename this object Waiting Room. We'll double-click up here and type in Waiting Room. Let's now build the logic for getting a patient to arrive, walk to the kiosk, sign in, and then take a seat in the waiting room. To do this, we're going to use what are called process flows. The process flow tool in the software allows us to build a flowchart of our model's logic. Inside that flowchart, we'll add activities that contain small chunks of pre-programmed logic or instructions. When the model runs, small green dots called tokens can be seen moving from one activity block to another in a process flow, performing each activity's instructions. Okay, let's begin by clicking the Patient Flows button on the main toolbar and selecting the Add a Patient Process Flow option. The first time we add a patient flow process, the software will automatically add a general process flow as well. The general process flow that is added is named arrivals and is a starting point for defining patient arrivals. Let's click on the Arrivals Process Flow tab. Notice that there is a stacked block of 4 activities in the arrivals process flow. The first activity creates tokens according to a specified schedule. The second activity creates a patient in the 3D model and attaches the patient to an instance of the patient flow process. The third randomizes the patient's appearance, and the fourth activity removes the token. Okay, let's take a look at the properties for the Create Patient activity. To open an Activities Properties window, we want to click the icon of the activity, not the name of the activity. You'll quickly come to learn when you need to click on the icon versus the name of the activity. Let's briefly consider the different fields in the properties of the Create Patient activity. This first field, titled Patient, is where we specify the type of 3D object we want to use for the patients created by this activity. The default option randomly creates men and women with a 50% probability of either sex. This next field we typically won't change. It simply specifies which label on the token will refer to the patient that gets created and whether the data overwrites previous data or is inserted at the front of the label's data structure. This field, called Destination, is where we specify the location in the 3D model where we want patients placed as they're created. This field is where we can choose which label set we want assigned to our patients. This will be explained in more detail later in the tutorial. And this last field is where we specify the patient flow process we want the patients to use. Notice it is currently showing the patient flow we just added to the model, which is exactly what we want. The only property we are going to edit at this time is the destination. So let's click the sampler button next to the destination field to enter sampling mode. Now, click on the glass door in the 3D model view to choose it as the destination for the patients that are created. Let's now switch over to the Patient Flow Process tab. Notice that this process flow already has a scheduled source activity in it. This activity will create a new token each time a patient is created by the Create Patient activity over in the Arrivals process flow. We will add activities to this process flow that will basically instruct patients to acquire locations, walk there, and spend some time there. In the library, on the left pane, under the HC Activity Sets panel, let's drag a Walk Then Process activity set into the Patient Flow window. This will create several activities at once. Activity sets are time savers because with one click we get several activities grouped together in a nice organized container for accomplishing common tasks in healthcare. We'll use this activity set for instructing the patient to walk to the kiosk and check into the clinic. A suggested workflow for defining model logic in a process flow is to first create the activities and/or activity sets we think we'll need, rename the activities to help identify their specific purpose, and then make connections between the activities where it's needed. And then later, we can edit the properties of those activities. Okay, with this in mind, let's rename the activity set we just created Sign In. Next, let's click the location resource within this set and rename it Kiosk. Now we need to click and drag a connection between the source and the sign-in container. As a note, we can either make connections between individual activities found within containers or between the containers themselves, and this software will intelligently work out which activity within a container the connection should go to. We will typically make our connections to and from the containers. As a tip, pay attention to the icon displayed for the mouse pointer before click and dragging connections. This will help you better predict when a connection will be made versus when the activity or container is going to be moved or resized by clicking and dragging. The mouse pointer icon is the key to what will happen when you click and drag. We're now ready to add another Walk Then Process activity set to instruct patients to walk to the waiting room and take a seat after they sign in at the kiosk. This time, we're going to use a different method to create the activity set in our patient flow. It's a quicker, simpler method, and one which we'll use throughout the rest of this tutorial. If we double-click in an open space of the process flow window, it will bring up a quick library to choose the activity or activity set we want to create. Until you're familiar with the quick library icons, you can just hover your mouse pointer over the icons and read what they are. Yet another option for adding activities to a process flow, which can save even more time because it combines the step of making a connection, is to click and drag a connection from an activity or container to a blank area of the window and simply release the mouse button. The quick library window will pop up for us to choose what we want to create. In this case, we want to choose this icon for the walk then process activity set. See how we created the new activity set and made the connection all in one step? Where possible, we're going to use this method when we create new activities or activity sets. Click, drag, release. Now, double-click this container's name to rename it Wait. Now, double-click the location resource in the container to rename it Waiting Room. We do not want the process activity that is in this wait activity set, so let's remove it. The slickest way to do this is to first pull it out of the block. To do this, we simply need to hold the control key down on our keyboard while clicking and dragging the activity out to a blank area of the window, like so. Then, press the keyboard's delete key to delete the activity. If you're having problems dragging the activity out, you're most likely clicking on the activity's icon rather than its name when trying to drag it. Also, make sure you have the control key pressed down. So far, we've added a couple activity sets, renamed a few things, and made some connections. Now, let's edit activity properties to get things working. So click the icon, not the name, of the kiosk activity to open its properties window. Next to the location box, click the sampler button, and let's sample the kiosk 1 object out in the 3D view. Now, we'll edit the process activity to define the time it takes a patient to sign in. Click the icon of the process activity to open its properties, and we'll change the average time of the exponential distribution that's already defined in this field from minutes parenthesis 10 to minutes parenthesis 3 parenthesis. We can discuss how to use statistical distributions to more accurately model the random behavior found in real-life processes later. For now, we're just going to make the changes as shown. As a side note, it is a recommended best practice to use a command like minutes, which we've used here, or one of the other similar unit commands like hours when entering process times. This is to avoid mistakes of entering process times in units not matching the unit settings of the model. If we didn't use the minutes command here, we would have needed to type 180 since the time unit settings for our model is seconds. Using a unit command like minutes, it doesn't matter what the model unit settings are because the command will properly convert the value passed to the command into minutes regardless of the model units. It's always a good idea to save as we go, so we'll pause what we're doing and save the model. We can use the File menu or click the Save icon on the main toolbar. It's now time to test what we've done by running the simulation. Before starting the simulation, we always want to first press this Reset button. This will clear out any previous run of the model and reset everything to its initial state. Now we can press the Run button and start the simulation. As we watch the model running, we'll see a patient arrive at the door in the 3D view, walk to the kiosk, and delay for an amount of time equal to their sign-in process time. Then they will walk over to the waiting room and sit down. Notice the simulation clock displayed on the toolbar is ticking away. The simulation is progressing at 4 times real time, but this can of course be changed by us using this slider or this drop down to define a specific speed ratio. The stop button can be pressed at any time to pause the simulation. And then to start the simulation running again from the point we stopped, we'd simply need to press the Run button again. This Step button is used to jump the simulation forward in time to the next event in the model. The animation in the 3D model view correlates with what is happening over here in the process flow view. As a token moves through the process flow activities, it governs the patient's actions in the 3D model, so we can use this view to interpret and debug our process quite easily. The process flow activities define all the actions and logic for the patients and staff. Okay, let's reset the model and begin adding some more 3D objects to our clinic. Previously, we were dragging out the 3D objects from the library into the 3D view. Now we're going to use a slightly different method that works well when we need to add several objects of the same type, like we do with the exam tables. In the library, under the Healthcare group, click the location icon to open a panel showing all the location shapes. Then click, don't drag, the exam table icon to select it as the type of object we want to create. And notice how the mouse pointer changes shape, indicating we are in the Create Objects mode. As long as we're in this mode, we will create the object type we currently have selected in the library with each click of the mouse in the 3D model view. Let's create 4 exam tables in our model by simply clicking the spots on the floor plan where we want to add exam tables. To exit the Create Objects mode, we can either press Escape on the keyboard or right-click a blank area of the view with the mouse. We need to rotate tables 3 and 4 to point the opposite direction. Now here's a useful trick we can use for changing parameters on more than one object at a time. All we have to do is select all the objects we want to edit. To do this, we hold down the Shift key while dragging a lasso around the objects we want to select. The Shift key is used when we're starting a new selection set, and the Control key is used when we want to add or remove objects from an existing selection set. So, keep in mind those 2 keys, Shift and Control, when defining selection sets. Now, we need to click on one of the objects in the selection set that we want to edit. Let's click on Table 3 and start editing. We'll change the Z rotation in the Quick Properties window to 180. 180. After clicking off the edit field, notice how both tables are updated with a new rotation. To deselect our 2 exam tables, we just hold the Shift key down as if we were starting a new selection set and then click in a blank area of the screen. Next, we'll add a scale object where the patients will be weighed before they're taken back to an exam room by a nurse. This object is located in the location group of the library. We need to rotate the scale to face the opposite direction. We can do this by typing the degrees of rotation into Quick Properties or simply right-clicking the blue Z-axis sticking up through the scale and dragging the mouse up or down while holding down the right mouse button. If an exact rotation is desired, of course, it may be easier to type the rotation amount into Quick Properties directly. Next, we'll add a computer desk to the model. This object too can be found in the location group of the library. Let's rotate the desk 90 degrees and move it over a little bit. Next, we'll create a nurse station in our model. These can be found in the prop group of the library. Let's choose the nurse station B shape. Let's rotate the desk 90 degrees to better fit the floor plan. Now let's add staff. In the library, click the staff icon to open a menu of staff objects. The staff choices you see should only be considered a starting configuration that can easily be modified to represent any staff type we want. After adding staff to the model, we can reconfigure them using options in Quick Properties panel to change their age, gender, skin color, clothing, etc. We won't bother changing any of the graphics for the staff in this tutorial model. We'll use the RN female and RN male staff without any modifications for the 2 nurses we need in this model. Let's place them in front of the 2 computers shown on the desk of the nurses station. Next, let's add 2 doctors to the model using the MD female and MD male shapes. We'll place them right behind our nurses for now. We are now going to assign objects we have more than one of in our model to a specific group. For instance, we're going to assign all the exam tables to a group we'll call exam rooms. And we'll assign the nurses and doctors to groups we'll call RNs and MDs, respectively. The purpose of groups is to organize and classify objects that have a common logical function. Let's begin with the exam tables. First, select all 4 exam tables using the shift-click-drag method we used earlier. Then we need to right-click on one of the tables in the selection set, bringing up a menu where we can point to Locations Group and click Add to a New Group. This will create a new group in the model, add the currently selected objects as members of the new group, and open the Properties window for the group. All we need to do is change the name of this group to Exam Rooms. Notice that all 4 of the exam tables we had selected are members of this group. Also note that the parent group for this group is another group named Locations. All locations are automatically added as members of the Locations group. Next, let's assign our nurses to their own group. First, we select both nurses using shift-click-drag. Then, right-click one of them, point to staff groups, and select Add to a New Group. We'll call this group RNs. Now let's assign our doctors to their own group. First, select both doctors using shift-click-drag. Right-click one of them, point to staff groups, and select Add to a New Group. We'll call this group MDs. To clear out our selection set, we simply press and hold the Shift key while clicking a blank area in the 3D view. And this should deselect everything currently selected. It's now time to add the patient flow activities for escorting our patients from the waiting room to the scale to be weighed and then on to their exam room. Let's begin by adding another escort then process activity set to our patient flow. To do this, we'll drag an output connection from the wait container and release it here. Then select the escort then process activity set. We'll double-click the container's default name and rename it Weigh at Scale. We also want to rename the location resource in this activity set to Scale and rename the staff resource RN. Now, let's edit the Scale resource. Click the Scale Activities icon to open its properties and click the Sampler button next to the location field. Then we'll click on the scale in the 3D view. Now let's edit the RN resource. Click on its icon and click the Sampler button for the staff field and sample either one of the 2 RN objects in the 3D view and then select the RN's group as the staff resource. Okay, when a nurse is required from this resource block, then the process flow will choose the first available nurse from the RN's group. Let's now define the time for weighing the patients at the scale. This is done in the properties of the process activity in this container. Click on the process activities icon, and in the expression for the process time, let's change minutes parenthesis 10 to minutes 1. We do not want to release the RN at the end of this activity set because we plan on using this same RN we acquire in this activity set in the following activity sets we're going to add. So, to delete this release activity, we're going to press and hold the Control key down, then click the Release RN activity on its name, not its icon, and drag it out of the stacked block group and drop it into a blank area of the window. Now press the Delete key and it'll delete this Release RN activity. Let's now create an escort then process activity set downstream of this Weigh at Scale activity set. This will be used for escorting the patient to their exam room. So first, we drag a connection from this container, release in a blank area below, then choose Escort then Process Activity Set. We'll rename the container Bed Placement. Next, we'll rename the location resource exam table. Then we'll edit its properties. So click the icon of the exam table, click the sampler button for the location field, and let's sample any of the exam table objects in the model and choose the exam rooms group option from the pop-up menu. The location field should now read any member of exam rooms. Next, we need to define which staff member will be used to escort the patient. In this case, we want the same RN who weighed the patient at the scale. First, we'll click the icon of the staff resource to open its properties, click the staff field sampler button, and sample the RN staff resource up in the weigh at scale container, because we want to use the same RN who weighed the patient. The field now reads reference to RN. We do not need the acquire RN activity in this activity set because, once again, the RN is still acquired from the previous activity set. We're going to use that same RN. So let's delete it. Once again, we press and hold the control key, click the acquire RN activity on the name of the activity, drag it out of the stacked block, and delete it. There's another little adjustment we want to make to this activity set. We want to move the acquire exam table activity in this activity set up to the beginning of the weigh at scale process flow. This is because we want to ensure the patient has an available exam room to go to before they're brought back to be weighed at the scale. We'll press and hold the control key to drag the acquire exam table out of this stacked activity block into the activity block up in the weigh at scale container. And we want it to be the first activity in that block. The next step of the process flow is to have a doctor examine our patients. Let's drag a connection down from the bed placement container, release the mouse button here, and choose Process with Staff activity set. We'll rename the container MD Exam and rename the staff resource MD. Now let's edit properties. We'll click the icon of the MD activity to open its properties and use the sampler next to the staff field to sample any of the MD objects in the 3D view, and then select the MD's group option from the menu. The staff field should now read any member of MDs. Let's now change the process time for the MD examination by opening the properties of the process activity and change minutes parenthesis 10 to minutes parenthesis 30. After the MD examination, we're going to have the nurse and doctor get together to discuss the patient's case. And for this, we're going to use the two staff meet activity set. So we'll click and drag a connection from the MD exam container and choose this activity set. We'll rename this container consult. We need to specify the two staff who will meet. First, staff 1. Click the icon of the staff 1 resource to open its properties. Next to the staff box, click the sampler button and sample the RN asterisk staff resource in the bed placement container up above. The field now should read reference to RN. In other words, the same RN who weighed the patient and brought them back to the exam room. Now the second staff. Click the staff 2 resource and use the sampler button to sample the MD staff resource up in the MD exam container. The staff field now reads reference to MD for staff 2. Next, we'll specify the location where the consult meeting will take place. So let's click the icon of the office variable to open its properties. Click the sampler button next to the variable or value field and sample the computer desk 1 object in the 3D view. The final step in the process flow will be to escort the patient to the exit. So let's click and drag a connection down from the consult container and release. Then choose the escort to exit activity set. We need to define which staff will escort the patient, so let's click the staff resource to open its properties. We want to use the same RN that was used earlier for this patient. We can specify this like we've done previously by sampling one of the RN resource boxes in an earlier activity set, or we can click this down arrow just to the right of the staff field and choose the menu option Previous Staff Resource. Next, we need to define the location of the exit. Let's click on the icon of the exit variable to open its properties, and click the sampler button next to the variable or value field to sample the glass door object in the 3D view. One more important modification we need to make is to change where we release the exam table resource in this process flow. We don't want to release the exam table until the patient is ready to leave, so we're going to drag the release exam table activity out of the stacked activity block of the bed placement container and move it into the beginning of the stacked block of the escort to exit container. Now would be a good time for us to save the model. So let's click the File Save button on the main toolbar. Now let's test our latest modeling efforts by running the simulation. We'll first press the Reset button and then press the Run button to start the simulation. As we watch the 3D model run, we should see the patient walk to the kiosk from the front door, spend some time. Let's hit the Step button and watch the patient then walk to the waiting room and take a seat. If an exam room is available, which it is, we should see the RN come to the waiting room, get the patient, and escort the patient to the scale. Spend some time representing the weigh time at the scale. You can hit the Step button. Then both the nurse and patient will proceed to the exam table. Next, the doctor will walk to the patient and spend some time for the examination. After the examination, the nurse and doctor will meet at the computer desk to consult about the patient. At the completion of the consult, the nurse will go to the patient and escort the patient to the exit. Of course, the timing of all these events is contingent on the availability of both the staff and locations needed for the activities. With only one patient, there's not a problem with availability, but once we increase the patient arrivals, there will be competition for available resources. We're now going to add a little more complexity to our model by defining two possible treatment tracks for patients to take. Let's stop and reset our model. Following the MD exam, a patient will either receive an EKG test within their room or be taken to the imaging room for an X-ray. Let's begin by adding an X-ray machine to our model. The X-ray object can be found in the location group of the library, and we'll drag it into the 3D view and place it in the back imaging room shown on the floor plan. The machine will need to be rotated -90 degrees. We're now going to add a couple wheelchairs to the model. These will be used to transport patients to and from X-ray. In the transport group of the library, let's select the wheelchair shape. We are now in the Create Objects mode, so we can create two wheelchairs by simply clicking twice in the 3D view. We'll place the wheelchairs in the back out of the way here. Next, we need to add an EKG machine. We'll drag out a portable EKG from the equipment group in the library and place it in this room for easy access. Now, let's add two radiology techs for handling the EKG and X-ray testing of patients in our model. We'll select the tech object in the staff group of the library. We're in Create Objects mode, so we can now simply click here and here to place the two techs in the central corridor of the clinic. We can exit Create Objects mode by right-clicking in the 3D view. Let's now create object groups for the new objects we've added to the model. It's always a good practice to create object groups in those cases where we have more than one object of the same type in our model. We'll start with the wheelchairs. First, we'll select both wheelchairs using Shift-Click Drag to lasso them. Then right-click one of the wheelchairs, point to Transport Groups, and select Add to New Group to open a Group Properties window. In the group name box, we'll rename this group Wheelchairs. and close the Group Properties window. Now for the text. Select them both, right-click one of them, point to Staff Groups, and select Add to New Group. In the Group Name box, we'll rename this group Text, and close the Group Properties window. Even though we only have one portable EKG machine in the model, we're going to create an object group for it as well. It can be a good idea to put even a single object into a group if there's a chance we may want to explore adding another object of the same type at some point in the future. It'll allow us to easily scale up without needing to change any process flow logic when we do add a second EKG machine. First, let's deselect the text by holding down the Shift key and clicking a blank area of the view. Now we'll add the EKG to a group as we've done before by right-clicking the object, point to Equipment Groups, and select Add to New Group. We'll rename the group EKGs and close the group window. We're now ready to modify our patient flow. We're going to insert 2 alternate treatment tracks between the MD exam and the consult steps. We'll need to open up some space in the process flow first. We'll do this by moving the consult and escort to exit containers down a ways. We can shift-click, drag a lasso around the 2 containers, and drag them down together. Okay, now let's double-click in the space we've just created and create a decide activity. It can be found under the basic group here. Let's rename this decide activity Treatment Type ? Next, we need to move the end of the connector going between the MD exam and consult containers so the connection leads into the decide activity instead. We can simply click and drag the arrowhead to do this. It should snap to the container. Let's first define the EKG track. From the decide activity, let's drag a connection down here and release, then select the Move Equipment, then Process activity set. It's this icon that looks like a person pushing an empty wheelchair. We'll use this activity set to have a tech bring the portable EKG machine to the patient, conduct an EKG test, and return the machine to its storage location. Let's rename this activity set container EKG. Inside the container, we'll rename the equipment resource also EKG. And we'll rename the staff resource in the container EKG Tech. Let's make a connection between the EKG container and the consult container for the flow out of this EKG track. Now we'll edit some of the activity parameters in the EKG container. First, let's specify the equipment resource. So we'll click the icon of the EKG activity to open its properties and use the sampler button of the equipment field to sample the EKG object in the 3D view. The equipment field should now read any member of EKGs. Next, let's edit the EKG Tech resource activity. We'll use the sampler button to sample the text group from one of the tech objects in the model. We need to insert an additional activity into this container that will instruct the tech to return the portable EKG machine to its storage location after using it. We'll use the Move Equipment activity to do this. We could first create this activity, then drag it into the activity block, or we can eliminate the drag step by doing this. We simply need to double-click the division line between the process and release EKG Tech activities to open the quick library, and then select the activity we want to insert. We'll choose the Move Equipment activity found under the HC Subflows group. Notice how the new activity is inserted between the 2 activities. Let's rename the activity Return EKG. We need to edit 3 fields in this activity, so let's click to open its properties. Using the sampler button for the equipment field, we'll sample the EKG resource in this container. The equipment field should now read Acquired EKG. Next, let's click the down arrow next to the destination field so we can select Equipment's Reset Position as the destination. For the staff field, we'll click the sampler button and sample the EKG Tech resource in the container. The staff field should now read EKG Tech. Let's save the model and see what we have working so far by running this model. After the MD exam, a tech should now bring the portable EKG machine to the patient, and after a brief delay representing the EKG test time, the tech should return the EKG to its storage location. Let's see if that happens. All checks out. So we'll continue and add the second treatment option. For the second treatment option, a patient will be transported to the imaging room in a wheelchair, receive an X-ray exam, and then be transported back to their exam room. Let's begin by dragging a second connection from the Decide activity. Release it here and select the Transport Patient Then Process activity set, whose icon looks like a patient being pushed in a wheelchair. Let's rename this activity set container X-ray and rename the location resource X-ray and the transport resource wheelchair. And finally, we'll rename the staff resource tech. We need to be sure and connect up this X-ray container to the consult container as well. Now, let's define the three resources used in this container. First, the X-ray location resource. We'll sample the X-ray object in the model. Next, the wheelchair resource, where we'll sample one of the wheelchairs in the 3D view and choose wheelchairs group. The equipment field should now read any member of wheelchairs. And finally, the tech resource, where we'll sample one of the techs in the 3D view and choose techs group. The staff field should now read any member of techs. We're going to need to add a couple more activities to this activity block in this container to accomplish everything we want to do. The default activity set handles the transporting the patient to the X-ray machine and performing the X-ray, but it doesn't include transporting the patient back to their exam room, nor does it include returning the wheelchair like we want to do. So let's double click on the division line after the process activity to bring up the quick library, and then we'll select the transport patient activity found under the HC subflows group. Let's click on the icon of the activity we just created to open its properties, and then use the sampler for the destination field to sample the exam table resource up above in the bed placement container. The destination field should now read acquired exam table. Let's now click the sampler button next to the staff field and sample the tech resource of this container. The staff field should read acquired tech. Next, we'll click the sampler button for the transport field and sample the wheelchair resource in this container. The transport field should read acquired wheelchair. We still need to insert an activity to return the wheelchair when we're done with it, so we'll double click the division line after the transport activity we just added and select the move equipment activity. Let's rename this activity return wheelchair. Now let's click on this activity's icon to edit its parameters. For the equipment field, we'll want to sample the wheelchair resource in this container. And for the destination field, we want to click the arrow next to the field and click the option titled Equipment's Reset Position. For the staff field, we will sample the tech resource. To test the X-ray treatment track, let's make a temporary change in the properties of the Decide activity. Let's change the Send Token To field to send everything to connection number 2. Just need to type a 2. Time to save the model. File save, or click the save button here. Now let's reset and run and see if the X-ray track is working the way we expect. After the MD exam now, we should see a tech grab a wheelchair and take it to the exam room and pick up a patient. Wheel the patient to the X-ray, put the patient on the table and spend some time representing the X-ray time. Then wheel the patient back to their exam room. Everything appears to be working correctly. It's time to increase the number of patients arriving in the model. Let's switch over to the Arrivals Process Flow tab and edit the source activity. There are several options for defining patient arrivals in a model. The arrival activity we're using in the arrival process flow is a date-time source by default. We'll continue to use this particular type of source in this model and simply bump up the number of scheduled arrivals. Let's open the source properties window and click the Edit Arrivals button. This opens a scheduling table where we can define when and how many patients will arrive. In the rows field at the top of the window, we'll enter the number 18 to create 18 arrival records. Notice that the table is updated with 18 rows. On each row there is a start time, end time, and a quantity field. The quantity field lets us specify the number of patients to arrive during the time interval defined by the start and end times. We will go with the defaults, which will basically create a single patient during each half-hour period from 8 a.m. in the morning until about 5 p.m. at night. Okay, we can close the arrival schedule and properties window now. It's time to randomly distribute patients between the two different treatment tracks in our model. We could do this directly in the treatment type decide activity using one of its standard options for choosing an output connector based on % probability. But we're going to do something a little different. We're going to create two different label sets for our patients and then make our routing decision at the decide activity based on the value of a patient label we'll call treatment or treatment type. First, let's define the two label sets for our patients. To do this, we need to go to the toolbox and double-click on the People Settings object. This will open the People Settings property window. Let's click the plus button next to where it says Label Sets to add a second label set definition in the table. Each of the label sets currently include two labels by default, a PCI label, which is an acronym for Patient Classification Index, and a label named Acuity. We want to add another label to each set, so we'll click the plus sign next to where it says Labels and choose the option to Add Number Label. We want to rename this new label, so we'll double-click the default name Label 2 and type Treatment. Let's call this label Treatment. We'll set the value of the treatment label to 1 for label set 1 and 2 for label set 2. Next, we're going to randomly assign one of these two label sets to each patient as they arrive in the model. To do this, we need to edit the properties of the Create Patient activity in the Arrivals Process Flow window. Let's click the arrow next to the Label Set field and select the Label Set by Percentage option. This will open a little properties window for that option. We're going to use a probability of 50% for each of the two label sets, so let's fill this out. Now let's switch over to the Patient Flow tab and edit the properties of the Treatment Type Decide activity to choose where it sends tokens based on the patient's treatment label value. In the Send Token To field, we're going to type the following: patient.treatment. Treatment is the name of the label, so we need to spell it exactly the same. So patient.treatment means the patient's label called treatment. And this statement will use the value of the patient's treatment label to determine which connector to send tokens to. If it's a 1, it goes to connector 1. If it has a value of 2, it'll go to connector 2. When we click on the decide activity, notice that each of the connectors coming out of it are labeled with a 1 or a 2, indicating the connector number. We're ready to save and run our model. Reset, run. We should see some patients receiving an EKG and some patients receiving an X-ray. Now that we have the patient flow working the way we want, let's create a dashboard to display some of the data being collected by this model. One of the charts we want to take a look at is called a milestone chart. For it to be a meaningful chart, however, we need to add some milestones to our patient flow. This is done by inserting milestone activities at key points in our process flow. For this tutorial, we'll add just one milestone activity so we can quickly see how milestones work. From the library, under the Basic group, drag a milestone activity into the patient flow and insert it before the split activity inside the consult container. Now we'll open its properties, and in the milestone name field, type end treatment as the name of this milestone. Now let's create a dashboard by clicking the Dashboards button on the main toolbar and selecting Add a Dashboard. The context-sensitive library pane on the left should now be showing a library of charts and graphs. If not, we simply need to click in the dashboard window. If we look under the patient templates group in the library, we'll see the AVG milestone times chart. By its icon, we can tell it will be a bar chart. Let's drag this chart into our new dashboard. When a chart is first created, its properties window automatically opens as well. If we want to open this properties window later, we simply need to double click on the chart. In the properties window, on the partitions/sorting tab, we can click the plus button next to where it says partition and select the option called patient label to partition the data based on a label value of the patients. And the patient label we want to use for partitioning is the one we named treatment. We can now click OK to apply our changes and close the properties window. Let's add one more chart to our dashboard. In the library, under the Staff State Templates group, we'll drag an AVG State pie chart into the dashboard. On the Options tab of the Chart Properties window, let's check the boxes for RNs, MDs, and techs so we can compare the state profile for all three of these staff groups in the same chart. We can now click OK to apply our changes and close the window. Let's save and run our model again to see if our dashboards are displaying data properly. Reset, run. We'll run the model really fast to see if the charts display anything. Looks like we're getting data displayed, so let's reset the model and put the finishing touches on it. Up till now, we've been letting patients and staff travel a direct path to their destinations, but now we want to make our model more accurate by defining areas where people can walk and where they cannot. To do this, we are going to use the A-star navigation functionality of the software, which essentially calculates shortest distance paths from one object to another, taking into account any obstacles between the two objects, and assigns the path to the traveler. Before we start working with the A-star navigation system, let's open up some real estate by closing the dashboard, and let's change our model view to a top view. We begin by first creating an A-star grid. This is done by simply dragging this grid object from the library into the 3D view. If we click on the blue boundary of the grid, we can use the red sizer arrows to stretch the grid so it covers our whole floor plan. With the grid selected, we want to edit the node spacing in Quick Properties. Let's set it to 0.5. This will give us more resolution for where to position things within the grid. Next, we want to double-click the A-star icon in the 3D view to open the A-star Properties window. On the Visuals tab, let's check the Show Grid Nodes box as well as the Show Travel Threshold box. I'll explain what travel thresholds are later. We can click the OK button to apply and close the Properties window now. If we reset the model, we should see the yellow grid nodes appear. We're now ready to add A-star dividers to the grid. These dividers will restrict where people can walk. For the most part, we'll use the walls shown on the floor plan as a guide for where to place our dividers, although it's not important that the dividers follow the walls exactly. In fact, in some cases, it may make more sense to place dividers off to one side or the other of a wall. To begin, we click on the divider object in the library under the A-star navigation group to enter the Create Dividers mode, and notice the mouse pointer changes its look. To create a divider, we simply click once to mark the beginning of the divider, then move our mouse pointer to another spot and click again to mark the end of a section of the divider. And we can continue to add divider sections like this, one after the other in a chain. When we're finished making a divider chain, we simply need to click the right mouse button. If we right-click just once, we'll stay in Create Dividers mode and are ready to start a new chain. If we right-click twice, we will exit the Create Divider mode altogether, and hitting the Escape key will also exit the Create Divider mode. Now I'll delete that divider chain I just made. Okay, let's begin by creating one long chain of divider sections all around the outside of our floor plan. Next, we will add dividers inside our floor plan, loosely following the internal walls as a guide for where we want to place them. Once again, though, it's not so important that the dividers are directly over the top of the walls. It's more important to keep in mind that the purpose of the dividers is to block travel across specific lines of the A-star grid. With some experience, you will quickly learn the behavior of this A-star system and learn to love it as I do. As you watch me lay out internal dividers, let me review some bullet points to keep in mind when creating A-star dividers. First, a right click is used to end a divider chain or back out of the Create Dividers mode. And we can left click in a blank area of the 3D view to start a new divider, or left click an existing divider node to start a divider from that node. We can freely click and drag existing nodes to adjust their position without the need to exit the Create Divider mode. And we can click and drag the 3D view itself to pan or rotate without leaving the Create Divider mode. Okay, that looks good for our dividers for now. We can always come back and add more or adjust the ones we've got or delete some if we don't like the way it's affecting our travelers. Oops, I just noticed that my waiting room is not rotated the way it should be. Let me fix that here. Okay, the next thing we need to do is connect the 3D objects within our model to the A-star navigation system. And any objects we connect will be seen as A-star barriers that people cannot walk through. First, let's connect the nurse station to the A-star Navigator by pressing and holding the A key down on our keyboard. And this will put us in connect mode, and notice how the mouse pointer changes its icon. Click on the A-star Navigator, and then click on the nurse station. This is one way to connect to the A-star Navigator. Now we'll do it another way. Let's double click the A-star Navigator in the 3D view to open its properties window. On the Setup tab, there is a member section. First, we'll check to make sure that all members is selected as the current member view option. Notice that the Nurse Station B1 object is listed as an A-star member already because we added it with the A-click drag method. We want to click this plus button to add more members. A pop-up window will appear showing all the current objects in our model organized by type. We're going to click Locations and Multi-Locations and Staff to highlight all three types, and then click the Select button in the window to select all the objects in our model that are one of those types. And we can see the names of all the objects that are now A-star members listed below here. We purposely chose not to add the front door as a member, by the way, because we do not want it to be a barrier for patients to walk around. We prefer our patients walk through it like they've been doing so far. All right, let me explain something to you about travel thresholds now. The travel thresholds for an object are visually indicated by red and blue dots on the A-star grid. Let's zoom in and look at one of the exam tables in the 3D view. The A-star navigation system uses travel thresholds to calculate the shortest possible path between two objects. An object's travel threshold represents the possible entry points a person may travel to when they are instructed to walk to that object. When a person is given instructions to travel to an object, the A-star Navigator will compute the shortest path between where the person currently is and any one of these red dots associated with the destination object. The person will then begin traveling along this shortest path. As soon as the person reaches any of the blue dots, FlexSim will consider the person as having arrived and the travel task will be complete. Well, why does this matter in this tutorial? Well, if the red dots of the object's travel threshold are on the wrong side of a divider, like it is here, it can potentially cause travelers to approach the object through the divider, and we do not want that. The way to fix this is to simply take care not to have a location's red travel threshold dots extend beyond any dividers that are adjacent to the location object. Let's check the travel thresholds for all potential problems in our model and adjust the position of either the divider or the 3D objects if necessary. Now let's see how our dividers are working by running the model. Let's first click reset, then run. The walking animation may not be as smooth as we would like, but no one appears to be walking through our dividers and other objects. There's a lot that can be done to smooth up the animation and make travelers take preferred paths, but we're not going to cover this now. Okay, let's stop and reset the model. Next, we're going to learn how to create tasks for our staff that are not related to any one patient. And we're going to refer to these as independent staff tasks. The first type of independent staff task we're going to make is the task of cleaning the exam rooms in between patients. In the software, these are called maintenance tasks and are defined on the 3D location objects where the maintenance task is to be performed. We're going to set up the maintenance tasks on all the exam tables at once. To do this, we first need to select all 4 exam tables. We'll do this by holding down the control button on our keyboard and then clicking on each table. Don't want to use shift click drag because we'll end up including dividers. Now, if we'll release the control button and begin editing the quick properties of any one of the objects in the selection set, the changes will be applied to every object in the set. This is a useful tip to remember when needing to make quick property changes to multiple 3D objects. The first change we'll make is to the maintenance condition field. The field currently reads 0.0, which is the numeric equivalent of false, meaning the maintenance task condition is not met and therefore will not be kicked off. There may be times where you'll want to use conditional statements, so maintenance tasks occur sometimes but not always. In our tutorial model, we want maintenance to always occur. So we'll change the condition to 1, which is the numeric equivalent of true, or in other words, the maintenance task will happen every time the location is released and vacated by a patient. We'll assume room cleaning always takes exactly 5 minutes, so we'll type minutes, parenthesis 5, close parenthesis, in the maintenance time field. Next, let's click the arrow next to the maintenance staff field to open a menu of options and point to group, then select RNs. We can shift click in a blank area of the 3D view to deselect our exam rooms. The next independent staff task we're going to make is the task of answering phone calls. For this, we will use a general process flow. The modeling method could really be used to model any sort of intermittent task that temporarily takes staff away from providing direct care for the patients. So keep that in mind. Let's begin by adding a phone object to the model. This time we will use the quick library to create a 3D object in our model, just to show another way of creating 3D objects. So double click in a blank space of the 3D view and a quick library will pop up. Click this first icon in the quick library for the location group of shapes and select the phone. We need to rotate the phone 90 degrees and position it over the top of the nurse station desk. We're going to use this phone as the location we send staff to when a phone call comes in. Now let's create a new process flow to simulate the arrival of phone calls and the tasks for staff to answer those calls. On the main toolbar, click the Process Flows button to open a menu and then select Add a General Process Flow. This opens a new window where we can create this new general process flow. In the Quick Properties pane, we'll change the name of the process flow to Phone Calls. We're going to start our flow off with a process with staff activity set. So double click in the process flow window and under the HC activity sets group, click on this icon of a person at a desk. Let's rename the container phone calls. And we'll rename the staff resource in the container clerk. Now let's double click a blank area of the window to bring up the quick library. And under the token creation activities, select the enter arrival source. Then we'll drag this source into the activity block, making it the first activity of the series. Next, we'll double-click on the bottom line of the activity block, and under the basic group of the Quick Library pop-up, we'll select a sync activity, adding it to the end of the activity block. Let's resize the container to fit the new activities we've added. Now, we'll begin editing the parameters of the activities. First, let's define the staff we'll use for the clerk resource. Click the arrow next to the staff field and select Staff by List of Choices. This will open a pop-up editor where we can specify multiple staff to choose from, as well as the selection criteria for choosing the staff. By default, it is showing 2 staff, but let's click the plus button here so we have 3 rows or staff choices to choose from. Click the down arrow of the first staff choice, point to staff groups, and select Group RNs. Click the down arrow of the next staff choice, point to staff groups, and select Group Techs. And finally, the last staff choice, click the down arrow, point to staff groups, and select Group MDs. We're going to leave the selection criteria with the default option of first available. So we're done editing this option. Now let's edit the parameters of the source activity. This activity will be used to generate tokens every 5 minutes on average, representing phone calls coming in. We'll click the Edit Properties button next to the Enter Arrival Time field and type minutes, (5) in the scale box for the exponential distribution. Rather than give a full explanation of statistical distributions at this time, let's just note we're using a popular distribution used for modeling inter-arrival times, and it's called exponential, and we're using an average of 5 minutes for the time between those arrivals, which in this case is phone calls. Now let's change a parameter on the Acquire Clerk activity. This parameter is tucked away in the Advanced section of the properties. By default, this acquire activity is set up to point to the patient as the object that is acquiring the staff, or what this activity calls the pooler. But these phone calls are independent of the patients and should be associated with just the token itself. Let's not worry about the details at this time, but simply know that we need to change the pooler to be the token itself. It should just read token in the field. Now, let's edit the destination in the properties of the walk activity. Using the sampler button to sample the phone object in the 3D view as the destination. Note that the person who will be walking is the acquired clerk. Next, we're going to edit the process time parameter of the process activity. Let's simply enter minutes, (1). This time of 1 minute represents the duration of a phone call. Next, we need to press the Advance button to show the involved resources of this process activity. We want to delete the topmost box that lists a patient as the first involved resource because patients are not associated with these phone calls in any way. We'll simply click the red X to delete it. We also want to change the name of the staff state assigned while they're answering a call. We'll change Providing Care as the name of the state to simply Performing Task. As an introduction on how to prioritize staff and other resource tasks, we're going to increase the priority associated with the task of answering phone calls in our model. To do this, we'll edit the properties of the clerk staff resource. The current priority level for tasks assigned to this resource is 150, which happens to be the default every task in the model is set to by default. We're going to change it to 200. A value of 200 will not only give priority to tasks associated with this resource, but will also cause staff to be preempted away from other tasks they may currently be doing. And this is because 200 is in a different tier than the value 150. Each tier in this software has 100 values. So 0 to 99 is one tier, and 100 to 199 is a second tier, and 200 to 299 is a third tier, and so on. Rather than go into this in further detail, I would refer you to the section in the user manual that talks about HC Staff and Resource Priority. That's the name of the section, HC Staff and Resource Priority. In the next step, we'll learn how to use the timetable tool to create a shift schedule for our nurses and doctors. The shift schedule will determine when staff members are off schedule, on a break, or generally not available to work on tasks. To create a timetable, we'll open the toolbox on the left and click the Add button to open a menu of tools we can add, and select Timetable. In the property window that opens, let's first change the name of the timetable to Shift Schedules. Now let's add all the staff in our model as members of this timetable. To do this, click this plus button, then click Staff, which you'll notice selects all 6 staff, and then press the Select button to add them all as members. Now we need to specify the scheduled downtimes for this shift schedule. This is done on the Table tab of the Properties window. First, let's set the mode to Weekly Repeat. Notice how the table view now shows the 7 days of the week as rows and the 24 hours of a day as columns. We'll add time blocks to this view showing the various down, or in other words unavailable times that make up a shift schedule. It can be helpful when creating downtime blocks to first set this Snap To menu to a chunk of time best suited for the block of time we'll be creating. For instance, in this first time block, we want to extend the block from midnight to 8:30, so it makes sense to use a Snap To of 30 minutes. Now it's just a matter of click and dragging a block from 0 to 8:30 for Monday. In the Down Behavior field, select Off Schedule for this block of time we just created. Now if we check this repeating event box for this new block we have selected, it will extend the block to the other days of the week, which is exactly what we want. Next, we need to create the off-schedule time at the end of the day. To do this, we can simply copy and paste what we already have here, this block of off-schedule times. So first we click the block of times we want to copy and press Ctrl+C on the keyboard to copy. Then move our mouse pointer to the right on the timeline and press Ctrl+V to paste. Standard Windows copy-paste shortcuts. We can drag and resize the block as needed to cover the time period from 1730 to 2400 each day. Now let's create the block of downtime for lunch. Lunch is going to be 1 hour from 1200 to 1300. So we'll leave the Snap To as it is set and click and drag a 1 hour block on Monday from 12 to 1300. We'll select lunch for the down behavior. Then to extend the block to all the days of the week, we'll check the repeating event box. Okay, finally we're going to include one 15-minute break in the afternoon. Let's first change the Snap To 15 minutes. And then click and drag a time block from 1500 to 1515 for Monday. For the down behavior, let's choose the Break 1 option and then check the repeat event box to extend the block to all the days of the week. Okay, we're done creating the staff shift schedule, so we'll press the OK button to save the changes and close the Properties window. And it's time again to save the model. Now let's see our latest changes in action. Click Reset and then Run. As we watch the model run, we notice that staff members only work during times they are not off schedule, or at lunch, or on a break. When staff are unavailable, a rectangular border will be drawn on the floor around their feet with a color matching the color of the associated down behavior that we set in our shift schedule. At this point, the model is essentially finished. However, we're going to learn one last trick that may prove useful in your future modeling. We're going to learn how to make our own custom location object. We'll be creating a new meeting place in the clinic where the nurse and doctor will hold their consult meetings. Let's begin by dragging the cylinder object from the library's prop group into the 3D view. To customize the object, first double-click it to open its properties window, all of its properties, not just quick properties. We'll name this new location object Meeting Place. Now, let's go to the General tab and modify the location's XYZ size, making it 2 by 2 by 0.01 meters. Next, we're going to customize the behavior of staff who arrive at this location. This is done using the Enter Instructions tab. We plan on creating two sets of instructions, one for the first staff member that enters the object and one for the second staff member who enters. The instructions will tell each staff member where to stand and which one of their animation clips to play. Okay, we'll begin by adding a role to the list on the left by clicking on the Add button. Let's give this role the name Staff. For the condition field, we'll use the option found in the drop-down menu titled Is an Operator. For the actual instructions, we're going to create two sub-roles under the staff role we just created. Let's create the first sub-role. This is done by selecting the staff role in the role list on the left. Click the arrow to the side of the plus button and click on the option to add sub-role. Let's rename this sub-role First. The condition for the first sub-role will be the option called First to Arrive. We'll add an instruction to this sub-role by clicking this Add button to open a menu of instructions and then select the Walk to Location option. Let's add two more instructions, a Set Rotation instruction and a Play Animation instruction. For the play animation instruction, let's choose the animation clip called Stand. For the walk to position instruction, we're going to take advantage of the planner person feature to help us define the XYZ position we want the staff member to walk to. So let's check the planner person box. This will add a temporary person out in the 3D view that we can drag to a position relative to the cylinder where we want the first staff member to walk to and stand. Then we need to click the Apply Planner Position button to update the XYZ position fields with the planner person's current location. The 000 for the XYZ rotation values in the Set Rotation instruction is exactly what we want in this case, so we're done with the planner person and can uncheck the planner person box to remove the person from the 3D view. The set of instructions are complete for the first staff sub-role. Let's now create the second staff sub-role. The instructions will be similar to those in the first sub-role, so we'll duplicate the first sub-role using this button here. Let's rename this sub-role Second. There is not a convenient condition option that specifies the second staff to arrive, so we'll type in our own conditional statement. We'll type role rank equal to for the condition. Role rank with a capital R is an understood variable in this condition field, and two equal signs are used when comparing two values rather than a single equal sign, which is used to set or update a variable, so that's why we're using two equal signs. We're going to want to use the planner person again to define the position where the second staff member will walk to, so let's check the box and let's position the planner person on the other side of the cylinder and rotate it in the z-axis 180 degrees to face the other direction. Then we need to click both the Apply Planner Position button and the Apply Planner Rotation button to apply both the position and rotation values. We can now uncheck the planner person box to remove the person, and the last thing we'll do is choose a different animation to play for this second staff member than we chose for the first one. Let's choose the Shrug animation option. Alright, this concludes the FlexSim Healthcare tutorial. So, let's save our model. Now let's press the reset button and hit run to watch our handiwork in action. Thanks for following along, and please press the like button to help others who are interested in FlexSim Healthcare simulation to find this tutorial video as well.